Yeah, yeah. Nice collection.
Yes. We've got a solar telescope here. We're just gonna,
You got one?
a solar telescope, this is.
Yeah.
Look at the sun.
Yeah.
And this one here, got the seagulls walking in front of it. This one's looking at the sun. So is this one.
Not a sunspot.
You'll see the sunspots in that one.
Yeah?
Yeah.
This one sees sunspots. It's got a special filter on it. See the disc in there. Just to the right of the centre.
I'm trying to get my eye on it properly.
It's a bright white disc, you should see.
Yeah, yeah. Although it's difficult to. Oh, hold on.
You can focus it a bit. There's a focuser there.
It's difficult to get your eye on the right part of the lens.
Yeah. They're all like that. You have to peer straight down the middle.
Well, I used to be an amateur, and I had an 8.5-inch reflector. I mean, this is years ago when I was late teens, early 20s.
Oh, that one.
And no, it was on an equatorial.
Yes.
But I never ever had a lens
It's a 2-inch.
like this. This is massive. I had the sort of 1/4 inch, the 1.25 inch, that kind of thing. Anyway, I'm actually here. See, that's a Celestron. No one's got a Mead.
No, not at the moment.
No.
The club scope was a Mead.
Yeah.
Haven't got it anymore.
What size was it?
It was a PT. It was a 90 millimeter.
All right. Okay. Refractor.
PST. It was a Schmidt stuff category.
Oh, okay.
This is a Schmidt category. It's a smaller version of this.
Right.
Not unlike.
Well, I'm interested to ask. I've never thought of this before, but I don't know if it would work. Does anybody do spectroscopic work?
We are planning to in our new observatory.
Right.
Yes, we're going to be doing that.
When you do spectroscopic work, if you during the day, right, you would say, well, what do you want to do that for? Well, it's for something completely different. If you're doing spectroscopic work and say during the day you're just to turn the telescope on the sky, or let's say you were looking at a star at night, that spectrum will obviously show the nitrogen and the oxygen in our atmosphere, won't it?
If it's present, yeah.
But
really, I don't know of anyone that does that during the day. It's always at night.
yeah, right. But I mean, if it's present, it's always present, isn't it? So it would show. The spectrum would show.
I don't actually know that. You wouldn't have thought of doing it during the daytime.
No, that's the thing. And you're thinking, well, why are you asking that? It's a strange thing doing it during the day. But the reason why, and this sounds a bit off the wall, but there's a good reason for it, is I would love, if I still had my telescope, which I haven't had for years, I would love to have been able right now to take views during the day, just of the sky, the ambient sky basically, but wait until a plane moved across the field of view.
Yeah.
And if I had the capability to take a spectrum analysis to see if I could see the elements that are in the plane's contrail.
I don't know if that's possible. I really don't know, actually. That's a good question. I've never heard that one before.
And you're probably thinking, why would you want to do that?
Yeah. Well, I like the idea.
Well, I can't see why you can't, because if you can take spectroscopy results from the sun or
point sources, when you've got light coming from every direction, it's going to be bleeding over. I don't know how much of a result you'll get from doing that. At night, you're looking at a point source, and the light is only coming from that.
Yeah, but that's why I asked. Even at night, you still have oxygen and nitrogen in the atmosphere, so that must show. Surely, it must pick that up.
I'm not sure actually,
because the light will be passing through.
The thing is, the light is generated by the sun, which has its own spectral lines. So you're just going to get a version of that. And the light that you see is sun refracted, isn't it?
Yeah, but it's passing through nitrogen and oxygen.
But it always does.
Yeah. So therefore,
when you get a spectrum anyway, it's coming through that, isn't it?
yeah, but the spectrum, therefore, that you're looking at must surely show nitrogen and oxygen. And therefore, you must sort of be able to say, okay, well, that's nitrogen and oxygen from the atmosphere.
I don't know how much it absorbs. I don't think it absorbs an awful lot of light in the atmosphere. Because, most of our spectral lines come through the atmosphere anyway.
Yeah.
And you're looking at the light as it's absorbed from the light source, the star. If it's coming through the atmosphere, I just think it'll be a version of the sun.
Oh, this is Jason Philip.
Yeah, it's me.
Hello, I'm Andrew Brown.
Hello, Andrew.
I'm the one who's often posting
Yes,
stuff on
I know.
Facebook. Yeah.
I know. So I'm just finishing up here. So this is going to be a really good question, but I'll have a
Well,
chat in a minute.
is there anyone who understands the spectroscopy better? No?
A little bit.
Steve might know a little bit more about me. I don't know that this could be done, to be honest with you. So,
I'm just trying to figure out, we're just having a chat about when you're taking spectroscopy and you look at a spectrum from the sun, but whose lights, you're looking at the spectrum of the sun's light or the star's light or whatever, planet's light, whatever. Now the planets aren't shining; they're reflecting, so their spectrum will be of their atmosphere.
That's right. Yeah.
Right. So, therefore, any light that comes through our atmosphere in the spectrum.
You have to take the absorption lines out of our own atmosphere.
Right.
Yeah. And
Right.
then what's left is what's coming from the sun, basically.
Right.
Yeah.
Good. Right. So that's what I thought.
Yeah.
Therefore, if the spectroscope is picking up our nitrogen and oxygen, etc.
Which is what it's doing. Yeah.
If you were, and you're going to say, why are you doing this? Why are you thinking of doing this? But if you were to turn the telescope onto an area of the sky where a plane has just passed over, and there's a contrail left, one of the big thick contrails, you would be able to pick up the spectrum, the elements of that contrail.
Yeah.
Right. And I would love to do that. And you're thinking, why? And that's nothing to do with astronomy. And I understand you're going, but that's not of interest to us. Because
we could try when our observatory's built. We could have a go at that. I don't
because
know how it would pick it up, though.
Well, if it picks up our, as they're saying, if it picks up the nitrogen and oxygen from our atmosphere, and you take that out.
I think it's more down to concentration, because in a contrail you've got a minimal amount of concentration compared to what's in our atmosphere. And spectroscopes aren't that sensitive when it comes
difficult
to
enough
that.
with the point
it's
source.
Very, very difficult. Yeah, because of the concentration.
But you don't know for sure. I mean, you don't know for sure.
You know how much roughly is in a contrail in terms of from the exhaust gases and what have you.
It's worth having a go.
The thing is, you're probably assuming that in the contrail, it's only water vapor. Therefore, what you're going to pick
Well,
up.
it won't be. It's a combination of water vapour, and there'll be carbon deposits from the fuel and from the burnt fuel and all that. You know, so.
Right. What if there's heavier elements in that contrail? See, what I'm trying
to by heavier elements.
Well, it could be various.
What, like mercury, things like that.
Where are you going? Where am I going?
You're not talking about chemtrails, are you?
I am actually, yeah.
Ah.
No, don't cast that aside.
No.
That is why I would love to be able to pick up
there's nothing wrong as an experiment with it, but I don't think you're going to pick up anything unusual.
No, you won't. And I don't think you're going to, with a standard spectroscope, you won't be able to pick up. You'll be very, very... There's not enough concentration. I mean, you're talking about parts per million in contrail compared to what's in the sky.
It's a really interesting question.
It's an interesting point, though, yeah.
John Carruthers, he knows more about spectroscopy than all of us.
Mr. Carruthers.
But I mean, it wouldn't take long. Just if you had a spectroscope on, if you get to that point, it wouldn't take long for
you onto someone who actually does spectroscopy. We can't do it yet. Our observatory's not built yet, but we will be doing it. I know someone that's doing it now. From CCAS.
From what?
Astronomical Society.
Yeah.
John Carruthers, his name is.
I mean, I know that, just as your reactions would be, right, but I'd just love to try it. just to see
You give it a go.
if something. It would only take minutes, you know. I guess.
No.
How long does it take to turn a telescope to, you
I
know?
remember a case a little while back where there was this hoo-ha about this particular plane, and it flew over central Wales up towards went over the Irish Sea, over the Republic of Ireland. Oh, chemtrails, they're poisoning us. You know what? I happen to know somebody who was on that plane. It was an overflight to Montreal from Paris. Yeah.
Yeah.
You want to know what's in,
I'd like to know what's in.
Yeah.
how polluting it is.
Yeah. It'd be very, very, very interesting. It
But
would
no,
be.
as an observation, it'd be very interesting, wouldn't
Yeah,
it?
it would be. It's worth it. I've never heard that question before.
No.
So how would I sort of
Well, okay,
make?
which would be a lot. I can.
So, but I just wonder how you would do it, because it's not a diffuse source, is it? It's spread out over a large area.
Well, that.
And I will then ask.
The only thing I could imagine you would do
Are you
is just
Jason?
narrow the aperture, wouldn't
you
you?
Jason?
You would just take a small portion of it and then take the spectra from that.
I will ask him. I've never been asked
There
that
are ways
question.
to do it.
Yeah, oh yeah.
You would use a. I guess you would use a pretty high magnification.
Yeah,
Get right
obviously,
into.
because you would need to get enough light in,
Yeah.
otherwise...
And it would be a matter of just sort of taking it out of the
out of what we
contrail
know
or
of the
chemtrail.
Earth's atmosphere, yeah.
Yeah, but moving it so that you would then take a spectroscope of outside the chemtrail or contrail, and then moving it back in and seeing if there was any difference.
Yeah.
I'll ask if it can be done. We'll see what John says. If he actually does spectroscopy, that's his thing.
That'd be great. I'd really appreciate that, man. I mean, even. Yeah.
Not something we do yet. We plan to, but we haven't built it yet.
Yeah. So other than that, what's in the sky these days of interest?
Jupiter's looking resplendent.
Jupiter's, yeah.
Absolutely, yeah.
Yeah.
Almost in opposition at the moment.
That was always my favourite. I used to. Oh yeah.
That's looking tremendous at the moment. We've got Mars and Saturn coming up in the next month or two.
Yeah.
And
Well,
Mars is already pretty good, isn't
It is, but it's early.
It's already pretty good, but it's still quite early still, yeah. But
Venus
it's
is an
already...
early morning one as well.
Venus is looking great.
any big changes in Jupiter over the last 10, 20 years?
Oh, about 2 years ago, we lost the northern equatorial band. It disappeared.
Yeah.
Yeah, we only had one brown stripe on it. It went for about 6 months, then it
Right.
came back. That's odd. Yeah, it did that. It does it every so often. You just lose an equatorial band. It did that 2 or 3 years ago, didn't it?
Oh, it's done that
Did it
before.
back
Yeah.
in the 70s
I mean, you
as
lose the red spot occasionally as well, don't you? So.
Only when it goes round the...
Never seen it.
But
I think the red spot is always visible, isn't it, whenever it's
always been
facing
there.
our
It's
way.
always there.
But we don't forget the
But I think there's
Jupiter
huge
rotates-
changes occasionally.
Because it rotates
Yeah.
every 10 hours, then people tend to think, oh, it's gone, but no, it's just gone round the back of the planet.
It's most likely ammonium cirrus clouds now blowing across the top of it, making it look more pink than red.
Yeah, Andrew's really into his planetary. So what he doesn't know, it's not worth knowing. So.
But
I used to.
the equatorial belt, that was because of a huge layer which went all the way around Jupiter of cirrus.
It was still there, wasn't it?
It was still there, but it was covered over, and then the Hubble took some images, and it could see it starting to reappear in tiny little spots. And then, as you say, it came back. Yeah,
It's covered the entire band. You expected to cover patches of it, the whole way. Really, why the north and not the south?
So-
yeah, it's really odd. We don't know why that was. Because it happened also with Pioneer 10. I don't know if you remember that. If you look at some of the old Pioneer 10 images, the same thing happened there. And the red spot literally was on its own in this huge sea of ammonia ice clouds. Yeah,
No idea why it does.
but we don't know why it does it.
Yeah.
I have a feeling it's a Hadley cell. It might be another one that's above the main one in Jupiter's stratosphere. But there could be a secondary Hadley cell.
It just affected the northern hemisphere,
Yeah.
didn't it? Yeah. He's in the sun, yeah. So, that'd be interesting. But yeah, contact me. I'll see if I can get an answer for you.
There's one there.
Yeah.
You see, and the thing is that I mean, I just looked at that 20 seconds ago, and it was very, very thin. But what happens is they spread out, and what you
sections of the aircraft itself.
yeah, but my understanding and a lot of people's understanding is that contrails should, being purely water vapor, and okay, a little bit of this and a little bit of that from the jet cell, but basically it should just